Hello, Professor. This is Rohini, and my teammates are Joseph and Likith. We worked on containerizing microservices, and we prepared a pipeline for that. So we got started with building the project, setting up the project. So, Spring Boot application. Basically, we have initiated the setup of the project involving creating a new Spring Boot application using Spring Initializer, following the link this one, and then we gave essential dependencies. Spring Data, GPA, and MySQL were included to support database interactions and persistence functionalities. API endpoints that we used are get mapping, post mapping, put mapping, and delete mapping, where we included the code in here under student.controller.java. So these annotations ensured that application could efficiently handle CRUD operations, providing a structured, clear way to create API routes for different HTTP operations. Then we created a model wherein the domain model classes are created to present the structure of the data that API would interact with. The model for the students table was defined the outline attributes and relationships necessary for application data handling. This model served as a foundation for database operations and data transfer. So these are the columns that we included: the first name, last name, the survey ID obviously, and address, city, zip code, phone number, survey data, campus love with, and why joining in, and recommended friends, all those columns. Then when it comes to service layer, in service layer, this was developed to encapsulate the business logic of the application. This layer provides a clean separation between the controller and data access layers and facilitated operations like adding, updating, updating, and deleting the records from the student table. It played a vital role in implementing the core functionalities of API. So here we create, update, add, survey were added here. And then when it comes to data access layer, then we have, so this Java file is used for database access layer. It acts as an access layer where the data is accessed. The data access layer was built using Spring Data GPA to manage interactions between application and database. This abstraction enabled the creation of repository interfaces that provide methods for standard CRUD operations without need for custom query implementations. So after setting these all up, we have a RAN application that has successfully run, giving us this message: Tomcat started on port 8080. So after compiling and building the application, we successfully able to run this on localhost 8080. Initially, it displays a blank page, error page like this. Then we will test the endpoint by giving the survey /1 or 2. These are the survey IDs that we can see later, but initially when we give, it gives an empty array. And the database configuration is like, So in this step, finally we did database configuration. For this, we have used Amazon RDS was configured to use MySQL as a database solution. The connection settings were integrated in Spring Boot applications application.properties, ensuring the seamless connectivity between applications and hosted database on AWS. So this is the file that we use to integrate the database solution, wherein we gave the URL, the database name, URL, username and the password. So next is to create and configure MySQL DB instance. So for this we have used AWS console, the AWS Academy console. So we navigated to AWS console. So to create database on RDS, we followed these steps. Select MySQL and engine version as 3.5. Select free tier and give the name of the identifier. Set the admin username and password. We have generated our own password here. And then we should go down, check all the settings and click on create database. So basically we should be selecting T2 micro instance class and give 20 GB storage, and then give the public accessibility and create the database. So elaborating the database connection, we took application properties file and configured all these, the database URL, authentication, the GPS settings, by giving all these values in here in this file. So once we run the application, then we could see that it had initiated the Spring Dispatcher servlet, and it can see the message Tomcat started on the port 8080. So to test the MySQL client, or to test the queries and to test the table, we have used dbware, wherein we can connect with the database that we have created on RDS and then run the query, so that it will list all the entries that we entered using put. So post. We post the JSON format from Postman like this, so that it will insert the data into the database. We'll come to this part later. So we use Postman for validating the API endpoints. So API endpoints are nothing but get, post, put and delete. These are the CRUD operations we have configured in this project. So we used the Postman to validate the API endpoints to ensure the connection to the database hosted on RDS. So we have installed Postman, and first the initial thing that we did is to fetch. So for suppose we have a survey ID with 1 here, you can verify it here. It's like this, name is Bob and Johnson. So if you want to fetch that particular tuple, then you can basically give the get request by giving this URL. This is our localhost /survey/1, and click on send, it will fetch the tuple. So next we can see the post operation that we're going to perform. So I'm going to insert this record inside the database. Now we do not have any of that record. So when I click on send, it will create the record for me. So if you go here and run, it will create a new record for me. Likewise, we have put is used to update the record. So I want to update 13 record that I just inserted, and then update with this new values. So I'm going to give Lily as new name for that record, and I have changed the zip code. So when I click on send, it will update. If you go here, now it's not like it will turn to Lily here and it will change the zip code. Let's see. If you run here, it changed the name to Lily and zip code is like this, which is matching with our request here. So next is delete. So if you want to delete the 13th record, we just have to give the survey ID here in the end and click on send. So if you go back to dbeaver and run the query again, gone, 13 record is gone. So we documented the same thing here. And next comes the git. So we have to push our code, the whole code, the project folders to git repository. For that we have created a repository, empty repository, and push the code to git. Next is creating a Docker image. So as we followed in the previous homework, we followed the same process. So we created the Docker file first with these commands or the code in my folder structure, and I have built the Docker image with this command, and then we verified the image to run it locally. So we mapped so it basically maps the port 8080 inside the container to 8081 on the local machine. Once the container is running, if we test on a local machine, we can see if we give 8181/survey, then it will fetch all the records that are inserted earlier through postman post operation. So the thing is, like, we have to log in with the Docker Hub to push our image, so for that we have to tag the image with our username and push it to the Docker Hub. This is the command to push our image to the Docker Hub. So once we push that, we can go to the repository created here, and we can see that I have given a tag 1.0, and this is my image. So for Rancher, we are going to create a EC2 instance like we did in the previous homework. So we launched two instances, one for Rancher and one for worker node, like this. So we have selected T3 large and given the security groups like this, and increased the storage to 30 and allotted elastic IPs to each instances. And then we ran sudo apt-get update on this to install Docker, and later we installed Rancher, and using the container ID we would we fetch the password to access Rancher. So we give that password initially when we open Rancher, then it will give us this interface where we can set our own password. So this is the command that we gave to retrieve the admin password. This is the bootstrap password. And then once we log into the Rancher, we create a cluster there, and once we create and verify these three things, or the configurations on the cluster, we just go ahead, copy this command and run on worker node. Worker node instance is another instance that we created. we should run that command on worker node EC2 instance. Then we can see this page. So once the rancher is completely installed and after creating, generating and running this on EC2 instance for worker node, then we can see this dashboard where we give the public DNS of rancher EC2 instance on the browser so that we can see the rancher. So what we did on worker node is like provisioning it. Once it is active, we work on the deployment. So we go to the deployments under workload section, and then give 3 replicas and the name, and we put this as default and pass our image that was created. Okay, and I have set node put service type and gave 8080 as private container. So once everything is done, we can go to the service tab and access this link. So if we go to the node port 8080 link under the services, we can see this link. So if you click on that link, you'll be redirected to this page. In the end, we should append survey/4. You can give any record here, for suppose 10, to fetch particular tuple. 10 Aditya. 10 is Aditya. So in that manner, we can access the application deployed on the cluster. Now next comes the Jenkins. We create another instance for Jenkins to install Jenkins and Docker on another instance to set up Jenkins. So launch this EC2 instance and associate it with one Elastic IP. First we install Docker on it and then Jenkins. We followed this link to install Jenkins. Once Jenkins is installed, we can check the status of the installation. If we see the active, then we can say that the Jenkins is installed successfully. To access it on a web browser, we give the HTTP and the public DNS public IP of that particular EC2 instance :8080. So once we are able to access that web application, we see the Jenkins page. Along with Jenkins, we have also installed kubectl to talk to the cluster and configure Kubernetes access for Jenkins. So we have to link up Jenkins with the Kubernetes in the so that we can create a pipeline. So this is the process. I made a directory like this and gave kubectl file content in it, and then we need to check the functionality. So we run this command called kubectl config current context. It will fetch the cluster name here. This is the exact cluster that we have created earlier. If we see here, this is the cluster name. It will fetch the cluster name. So when we open this link, if we initially we have to give the admin password. So on the EC2 instance, we go to this particular folder and fetch the password and paste it on Jenkins setup page, and we give all the other details, password, email and all, and that's it. We can follow the next steps to create a pipeline. So on Jenkins, we go to manage Jenkins, manage credentials, and under that we add two credentials, one for GitHub, the other one for Docker Hub. So once we add the credentials, we go ahead building the pipeline. So in the UI, if we click on new items, we can enter the name of the pipeline, and we need to give this to check to allow Jenkins to check every change that comes to the pipeline. So it's basically a periodic job that runs every minute. So we give this stars in here, and then connect our GitHub repository. So we should be selecting this option here under definition and add git repository and the credentials that we added earlier. So we should give the branch name here where we have all the files pushed, files and folders pushed, and we should give the script path as Jenkins file. After that, we go ahead create the Jenkins. Before that, we install certain plugins called GitHub plugin, Docker, Safe Restart, Maven, all these plugins on Jenkins. So whenever you install any plugin, Jenkins page will restart automatically. Then we configure environment variables. So the Docker Hub password should be passed in the environment variables of Jenkins files. So this is our Jenkins files. So we make changes on our Docker machine and push it. Once we push that, the pipeline will trigger, and it will build the jar file, create a Docker image, and deploy updated application on Rancher managed Kubernetes clusters. So if we go to the this link, when we have checked the application on Kubernetes cluster, the changes will appear there, and the pipeline will run like this, showing the progress. When we ran the pipeline, we got the progress like this. If we go to Jenkins, and click on build now, the build will be scheduled, and it will run the pipeline. These are the pipeline steps. So earlier we have seen the pipeline got broken because we should update or change the permission for Docker socket. So I have gone to Jenkins EC2 instance, ran this command sudo change mode 777/var run Docker socket, and restart the Docker. Once you restart the Docker, you can go ahead run the pipeline again. Now if we build it again, the pipeline runs. It's done. So basically, when the pipeline completes its cycle, it will detect the code push and build the jar file, create image again, and push it to Docker Hub, and deploy the updated application to Rancher managed Kubernetes cluster. So to verify that, we can go to Docker and see. Look at this. Few minutes ago, we have done that. In this manner, the image will build again.